this burn of things and all the rest. Something is the best for me.
How low can you go? How low can you go? How low can you?
Notation problem. N represents the number of binomials or expression. Number of binomials should be in each expression, so it goes up to the number 4. And then I represents your how much you increase for each expression. And then from there on, you just simplify and add all the terms together, and you get 38. Okay, so arithmetic is adding each term by the same number, and geometric is multiplying each term by the same number. So when you're doing the sum formulas, the whole point, either if it's arithmetic or geometric, is to try and get a sum at the end. So all of these numbers should add up to this and this. But you don't just add them up, you actually have to use 2 formulas for it. And Sn represents the sum, N represents the number of terms, first term, last term, and then sum, first term, and R is the common ratio, and N is the number of terms. So the difference for these series, trying to find the sum formulas, would be you're adding by a certain number to each one, and then you're multiplying by a certain number to each one. Okay, so the difference between arithmetic and geometric: arithmetic, you're adding a certain number each time, and then geometric, you're timesing a certain number each time. A sequence is separated by commas, and and series has addition, like addition signs. And how you would know if it's neither arithmetic or geometric is if there's no common ratio or no common difference. So say this was like a 9 and this was like a 10. It would not be +4 every time, so it would neither be arithmetic or geometric. The United States whole population is 300 million people, and if we were doing a pyramid scheme where 3 members were chosen and each member had to recruit 3 more people, the numbers would go in this type of order because each person would have to recruit 3 people. So for the 3 people that got picked, had to recruit, and then it just keeps going down and down through the pyramid of Sleeza. And then, so basically you have to find like a formula to use to solve like how many rounds it would take for like the whole population to be a part of this pyramid scheme. So we'd use the geometric. I think that's a series, series, this formula, and you would just plug in all your A1, your R, your N, and go through, and it would take just over 17 rounds.
Woohoo.
So now we're trying to find the number of participants in this pyramid scheme at the final round, which is the 17th round. So the 3 represents the members, and the 17 represents how many rounds we did. We ended up getting this large number of new recruits, but we had to use a geometric series to actually get the other number of participants. So this is the recruits as participants, and then you divide, and you would get the total number of recruits percentage. 66.7.
Wow.
At Vaughn's grocery store, you stack apples into a square pyramid. Once done, you notice the pattern of the top 3 layers has 1 apple, then 4 apples, and then 9 apples. This pattern continues for 15 layers. So when using scientific notation, we put 15 on top because that's our total number of layers, and then I on bottom, and then I squared. So it's basically increasing by 1 every time. So 1 squared is 1, and then plus 2 squared is equal to 4, and then 3 squared, which would equal 9, and you just can keep doing this in your calculator till you get the total number, which is 1,240 apples. But if we want to find the total number, or the total number of apples, we need to use this, but it's neither geometric or arithmetic. It has no common difference. So if it has no common difference, we use sum of squares, because this is +3 and this is +5, so there's no common difference. And this is the equation, and n equals number of terms, and you just plug it in and you get this number.
Yay!
Yay!
I'm an apple stacker expert. 1 apple, 2 apple, 3 apple, 4 apple.
Yay! So in this problem, we're talking about retirement investments and what we're trying to look into when you retire. So every year you deposit $6,000, but there's 7% interest. So year 1 you start with $6,000, then you go and basically you times by 1.07 because that represents the 7% interest. So we know it's a geometric series because you're multiplying by the same number, and we know that's how we know it's geometric, and we know it's series because there's an addition sign in between each term. So then you basically plug in the sum. You basically plug in the first term, the common ratio, and the number of terms to the formula, and then you'd solve down, and we come up with 661,285.7 cents as the total. Okay, so we already figured out what the 32nd year is. Now we're trying to find what the 31st year is. So we're basically trying to find how much money that we actually made in 1 year. So we take a geometric series formula to do this, and we'd basically plug in all the numbers we got from the last equation. Instead of it being 32, it's just 31. So we end up making that as our sum, and which means that you have to subtract what you got from the 32nd year and the 31st year to find how much money you make in 1 year. There's also a shortcut you can do, and you can just use a geometric sequence instead of a series, and you plug in for the last year and plug in all your terms, your N, your A1, and everything, and you'd get the same amount without having to do any of the other stuff. When does your account grow the most? Your account grows the most in the last year because it gains the most compound interest. Just like what we did with the 31st year and the 32nd year, it proved that $48,000 was a lot to gain in 1 year.
So for arithmetic, we are adding. I need to start over. Wait.
Head down. Down. Hey.
Oh! The homie. In the magazine, yeah. Oh. Video, Chloe. Wake up, Chloe. She says, no, I don't want to. I'm tired.
Fudge you.
This burn of things and